Okay, last section in chapter 2, and it really comes full circle with what we did in the first section. In the first section we talked about what's a whole number, what's an integer, what's a rational number. What is a rational number? Who remembers what a rational number is?
You can write it over a fraction.
You can write it as a fraction, okay? There's a lot of types of rational numbers. Some of them are listed back there on that number line on the back wall. What types of numbers are those called? Integers, very good. And then a small set of the integers, when you have just 0 in the positives, what's that, Riley?
Whole numbers.
Whole numbers, okay? So we talked about whole numbers, integers, rationals. Well, if something's not rational, then it's irrational, and that's what we're going to talk a little bit about today when we talk about square roots and different types of numbers. So square root, first one, definition is right here. If some number squared, so if some number times itself is b, then we call that number a square root of b. Can somebody tell me what the square roots of 25 are? 5 is 1.
5 is 0.
Minus 20.
Why is not minus 25, but you're close. You're
Minus 5.
minus 5. Okay, a lot of people forget about that one. But if you think about it, it fits the definition of a square root. Because what happens when you take 5 times 5? 25. So we say 5 is a square root of 25. What happens when you take negative 5 times negative 5?
Negative 25.
Careful. You get 25 again, so we can also say negative 5 is a square root of 25. But when you punch in square root on your calculator, what do you get? Does it say 5 and negative 5? All it says is 5, right? And that's because it uses that, you guys think it's called the square root symbol, right? It's actually called a radical symbol. Radical symbol. This is called the radical symbol. Whatever is underneath the radical symbol is called the radicand. The terms under the radical symbol. When you use this symbol in math, we're just referring to the positive square root. So that's why we can say, well, the square roots of 25, it's both 5 and negative 5. But if we use that symbol, we're only talking about the positive one. And all that's why when you punch it in your calculator, it just says positive 5. Okay. All right, next vocab word, perfect square. A number with a square root that's an integer. I like to think of them as the nice ones. A lot of times there's square roots, they go on forever, they fill up your calculator screen, but there's some that are really nice. Can anybody, what's that?
144.
144, yeah. Why? What's the square root of 144?
12.
It's nice, it's 12, it's an integer. What's another one that you guys know that's perfect? 25. Okay, I'm going to try to, maybe you guys want to list them here in the margin, I'm going to list them across the bottom. You got 25. Somebody said 144.
Are we listing all of them?
Well, we wouldn't have enough time in our lifetimes to list them all. But the ones I expect us to know are 1 through 12. Taishana. 36 is a perfect square because the square root is 6. Riley.
4. 81.
81. 81 because the square root's nice. It's 9. What are some others? Stuart.
49.
49. Square root is 7. It's nice.
4.
4. Square root is 2. Fish. 16. What's the square root of 16? 4. There's a couple other nice ones.
99. Or not 99. I just lost. Oh, 9.
9, yep. 9. Square root of 9 is nice. It's 3. Mark? 100. 10 times 10 is 100. Couple in there that we haven't gotten yet. Taishana? 64. Square root is? All right. Spencer, you got one?
What was mine? Was 64.
You had 64. Megan?
121.
121. Ooh, that's a tough one. Sometimes people forget 121. What's the square root of 121? 11. There's one up there that we're missing. Kian? 1. Square root of 1 is 1. So we've got 1 squared, 2 squared, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are the ones we have to have down in our memory. Okay? Anything above that is icing on the cake. Anybody know what the square root of You know what 13 times 13 is? 169. Anybody know what 14 times 14 is?
228.
196. 15 times 15?
Oh, 15 times 15 is 25.
225. 16 times 16? Close, 256. Yeah, you guys are pretty good. Pretty good, okay. So these are examples of perfect squares. They have nice square roots. Yes, sir?
How about 0?
0. Okay. You know what? I kind of like that. What's the square root of 0?
0.
Is that an integer?
No. Yes.
Yeah, so I agree. Let's throw 0 on that list. Okay, I like it. Okay, so the square root of a number, we just defined it. If b squared equals a, then b is a square root of a, and we actually use the same example, okay? 5 and negative 5 are square roots of 25. So if in words somebody says, what are the square roots of a number, you should have 2. But here they clarify if you use that symbol. It says all positive numbers have 2 square roots, a positive and a negative. The positive one is called the principal square root, and that's when we use the radical symbol. So let's try to work through these ones together. Who thinks they've got A? Riley.
Well, I just have a question.
Yes, sir.
So, like, 36, the square root is 6 and negative 6?
Okay, if I asked you in words, what are the square roots of 36? Yes, you would say 6 and negative 6. Okay? But when I use this symbol, I'm just referring to the positive, the principal square root. So what would this expression end up being?
6. Negative 6.
Shower, what do you think?
Negative 6.
But didn't we just say we're supposed to only have, this just refers to the positive?
Yep, they have negative.
Okay, so ignore the negative for a second. What's the square root of 36 when I use that symbol? 6. I'm just taking the opposite of that. So negative 6. How about this one? Square root of 16.
4.
Yeah, when we use that symbol, it just refers to the positive square root. When you use this symbol, it's a fancy symbol. It says you can have the plus or the negative, positive or negative answer. Well, ignore it. What's the square root of 64? 8, so we're going to have, we say positive or negative 8. Okay,
So
just
you can't
means
just write like negative 8, comma.
you could write 8 negative. You could write it like that as well. This is just a shortcut way. Some mathematician somewhere in the world got lazy and made a new symbol for it. Okay. All right, let's have you guys do checkpoints problems number 1 and 2. And I'm going to have to go fast because you guys are going to be fast on this one. Okay, square root of 100. When I use that symbol, what is it? Positive 10. How about here? The opposite of the square root of 1. Square root of 1 is 1. We find the opposite of it, negative 1. Okay, very good. Okay, over in the margin. This is one area we have nailed on the MCAs the last couple years. And I think taking this little time to add a little extra in there makes a huge difference. So in your notes, why don't you jot this down quick? Estimating square roots. This is a huge number sense thing that they like to hammer on the MCAs, ACTs, all that stuff. I call it the squeeze theorem. There's actually a squeeze theorem in calculus that you'll learn someday, but that's a long way down the road. So I'm going to use that idea here. If I want to estimate a square root, squeeze it between 2 square roots that you do know.
20. Right now it's 29, but it's between 25 and
I mean, I don't know what the square root of 29 is, but like Stuart said, hey, you know what? I know what the square root of 25 is. And I know what the square root of 36 is. What's the square root of 25? What's the square root of 36? So using this idea of squeezing, hey, I'm going to squeeze 29 between these things. That means the square root has to be squeezed between 5 and 6. Okay? Now, since 29 is closer to which one, 25 or 36? A little closer to 25, we could say it's going to be about 5. If 29 was a little closer to 36, maybe we'd say about 6.
So like no decimals?
No, usually they'll say approximate it to the nearest integer. Okay? If they say to the nearest decimal, then we use our calculator and we'd round it to 2 decimal places, nearest hundredth. Okay? And if you don't know how to use your square root button, please ask me. I'll help you out. Okay? It's just a couple little keystrokes and it makes a world of a difference. Okay? One more idea. What if we're asked to find a large square root? I know you guys know, I asked you to learn 1 through 144. Somebody comes along and says, what's the square root of 4,900? 4,900? Jeez. Well, look for something in there that's similar to something you do already know. Dahl, what do you think?
Square root of 497. So you just add a 0.
Add a 0. Why? Because if you have 70 times 70, hopefully you guys learned a trick in earlier grades that, well, ignore the zeros, 7 times 7 is?
49.
And how many zeros do you have?
2.
So when you have 1 0 and you add another 0, you got the 2 zeros. Okay, so to get 2 zeros, all I need is 1 0 when I take the square root. Okay, just little tricks. You can really impress people with that one. What's the square root of 81 million?
Well, let's see. Wait, 9.
What's the square root of 81 million?
9,000.
Taishana?
9,000.
Not 90,000, you're close.
900,000.
900,000? How was the show?
Yeah.
Remember, to create 2 zeros, you just need 1. Tipka?
90 million.
Not 90 million.
9,000.
Jaden?
9,000.
9,000. Square root of 81 is? 9. To create 2 zeros, I need 1 0. There it is. Square root of 81 million is 9,000. So just little tricks you can use to make square roots a whole lot simpler. Okay? All right, let me see something here. That can't be all we have today. I wonder if I messed something up. That's all we're doing today. Huh. How about that? Square roots today.
That's pretty easy.
That's not so bad.
And next tomorrow.